Hi, I'm Paul Kyogan from GK Tuition, and in this video I want to talk to you about functions, graphs and differentiation. Now the question that I've chosen to go through here is 2019 paper 1 question 7. In this question we're told that the flight of a camogie ball can be represented by the function minus 4t squared plus 16t plus 1. And we're told that t is the time in seconds from when the ball was hit. Now that's the key to answering part A. We're asked to find the height of the ball when the goalkeeper hit the ball. T is the time in seconds from when the ball was hit. So obviously the moment we're looking for, what was the height the moment the ball was hit? The moment that the goalkeeper hit the ball. Clearly if T is the time in seconds from when the ball was hit, that means that the moment the ball was hit, T is equal to 0. Because when she hits the ball, it's 0 seconds from when the ball was hit. So because of the way they've described t, that means the moment she hits the ball, t is equal to 0. And that's going to allow me to find the height. So all I need to do is sub into my function t equals 0 to work out what the height of the ball was. So I'm looking for f of 0. F of 0 would be minus 4 times 0 squared plus 16 times 0 plus 1. Which means that the height of the ball, the moment she hits it, well, clearly any number by 0 is 0. So this just works out as a 0, as does 16 by 0 is just 0. So I'm just left with 1. That means the height of the ball, the moment she hit it, was 1 meters. It was 1 meters above the ground when she hit it with the sliotar. Hit it with the hurl. So now, and also you have to be aware that it told me that the height is in meters. So you have to give your answer, it's 1 meter. The height of the ball when she hit it was 1 meter. In B part 1, we're asked to complete the table to show the height of the ball during the first 4 seconds of its flight. So we've actually already worked out one of these values, so I've only done one of them here. The function is f of t equals this. So the one I've displayed here is to work out the height of the ball after 0.5 seconds. That means you sub in, instead of t, you sub in 0.5. So I basically just rewrite my function, except instead of t, I just sub in my 0.5. And when you work that out, it works out as 8. Now, once you write that out, you can actually just plug it all into your calculator and get 8. That tells me that after half of a second, the height of the ball is 8 meters. We worked out in the previous part that after 0 seconds, the height of the ball is 1 meters. Now, you need to sub in, then you sub in 1 and your answer should be 13. When you sub in 1.5, 16, 2, you get 17, 2.5, you get 16, then 13, then 8, and then 1. So if you just think about what's happening, for the first 2 seconds, the ball is getting higher and higher. It reaches a maximum of 17 meters, and then it starts to go down again. So you need to work this out for each one of your values, but your answers in this case just look like that. In part 2, we were asked to use the grid given to draw a graph of the height of the ball over the first 4 seconds of its flight. So we just plot the points from B part 1. Along the x-axis is time, along the y-axis is the height. My first coordinate is 0, 1, then 0.58, 1, 13, 1.5, 16, 2, 17, 2.5, 16, 3, 13, 3.5, 8, and the last one then is 4, 1. So just make sure you're clear on plotting your points, and your graph should look similar to mine. Again, this is a curve, there's an x squared in it, which means it's a curve, which means you cannot use your ruler to join up your points. In C part 1, I'm asked to use my graph to estimate the length of time from the ball was hit before it landed on the ground. Now, again, it's said to show the work on your graph, so I suggest you use a different colour and you make sure that it's clear on your graph. The ball was hit at this moment in time. This is when the goalkeeper hit it. It goes up to here and then it comes back down, and I know after 4 seconds it's 1 meter from the ground. But obviously what I need to do is continue this line on. I need to continue it on, and I need to estimate the point where it hits the ground. Roughly, if you do that, that roughly works out as 4.1 seconds. It's roughly about 4.1 seconds from the moment she hits it until it lands on the ground. So the first answer for C part 1, you should get 4.1 seconds. Now in C part 2, we're asked to use the graph to estimate the length of time for which the ball is above 10 meters. So let's just go to 10 meters and let's draw a broken line across. Again, remember it said you have to show it on your graph, so this broken line is part of the marks. Obviously, when the black is above the red dotted line, that represents when the ball is above 10 meters. And from this period to this period, the ball is above 10 meters. And I need to figure out how long that is. So obviously I need to go down, so from this point to this point, I need to figure out how long that is. In order to do that, we need to draw a broken line down. Now obviously if you're doing this in your exam, you're using a ruler. The more, you need to be as accurate as possible, so you need to use a ruler. If I draw a broken line down, that's roughly 0.6 seconds. So after roughly 0.6 seconds, the ball is above 10 meters. Goes up and then it starts to go down, and it goes below 10 meters roughly here, which if I draw a broken line down, works out at roughly 3.4 meters. So there what I'm getting is 3.4 meters. So, sorry, not meters, seconds. So I know that from between 0.6 seconds to 3.4 seconds, the ball is above the ground. The ball, is above 10 meters. The question is, how long is that? So obviously what I need to do is just subtract 3.4 minus 0.6. 3.4 minus 0.6 means that the ball was higher than 10 meters for roughly 2.8 seconds. So your answer to that part is just 2.8 seconds. Okay, for D part 1, we're asked to find f dash t, or in other words, the first derivative of f of t. So in order to differentiate this one, it's relatively straightforward. If you're differentiating, it's t to the power of 2, the power comes in front. 2 multiplied by minus 4 is minus 8, and the power of t decreases by 1, so it becomes t to the power of 1. You could view this as 16t to the power of 1. And if I differentiate that, the 1 comes in front, 16 by 1 is just 16. And the t decreases to t to the power of 0. T to the power of 0 is just 1, so I can ignore it. And the derivative of a constant 1 is just 0. So my final answer, the first derivative, is minus 8t plus 16. In D part 2, we're asked to find the speed of the ball when it had been in the air for 4 seconds. Now, you should realize D part 2 is obviously related to D part 1. So even if you're a little bit unsure in your theory, it's obviously something to do with differentiation. The theory involved here is the original function f of t I've been given was the distance. It's a distance. It's the height the ball is from the ground. So it represents a distance. If you're given a function that represents a distance, the derivative of distance is speed. So in D part 1, I worked out the derivative f of t. Or in other words, I worked out the speed of the ball. The derivative minus 8t plus 16, this function, this minus 8t plus 16 represents the speed of the ball. And I've been asked to find the speed of the ball after 4 seconds. Or in other words, when t is equal to 4. So if I'm looking for that, that just means I sub in, everywhere there's a t, I sub in a 4. So that means I'm going to get minus 8 and t, instead of a t, I'm going to put in a 4. If you plug that in, minus 8 times 4 is minus 32, and I get plus 16. So my final answer there is minus 16. And obviously we need our units here. The speed in this case would be meters per second. Now the reason this is negative is because remember, we're talking about the height of the ball. So if the speed worked out positive, that means the height is getting bigger. That means the ball is going up. If this works out negative, that means the height is getting smaller. The ball is going down. So the speed of the ball is negative. That means that it's going down. It's getting closer to the ground. The height is decreasing. So your final answer here is minus 16 meters per second. In D part 3, I'm asked to find the time when the ball is traveling at 8 meters and it's descending. It's traveling at 8 meters per second and it's descending. If the ball is going down, that means that the speed is minus 8 meters per second. Remember the previous one, my answer was minus 16 because the ball was going down. This time, they're telling me the speed is minus 8 meters per second. And I'm asked to find the time when this occurs. Previously, we've said that the speed is equal to minus 8t plus 16. And now I'm trying to find the value of t for which the speed is equal to minus 8. So obviously I can just let these two equal to each other and find the value of t. So I can say that minus 8t plus 16, which is the function that represents speed, is equal to minus 8. We're trying to work out what is the value for t for when this is equal to minus 8. At this stage I've got one equation, one unknown, which means I can find the value of t. The first thing I want to do is bring the 16 to the other side, and it's clearly going to become negative. So I could say that minus 8t is equal to minus 24. Now, if both sides are minuses, I can just change the signs, or in other words, multiply both sides by minus 1, in which case 8t is equal to 24. If 8t is equal to 24, I can just divide both sides by 8, and I end up with t is equal to 3. And obviously time is represented as seconds, so t in this case is 3 seconds. 3 seconds after the ball was hit, it's going downwards at a speed of minus 8 meters per second. Now I hope everything in this video makes sense. If there's anything there that doesn't, just let me know in class or send me an email and I'll explain it differently.